Thank you, Tim. Hello, everyone. This is actually my first time at JSConf. I'm really excited to be here, and I'm really excited to talk to you about serverless apps powered by web components. So before we dive in, I just want to give a bit of context. So I work for The Guardian as a senior engineer, and I work predominantly on editorial tools, which is the main two being the new Guardian CMS called Composer and a new media service for managing images. Now, all these tools are built as web apps, and they follow the same sort of three-tiered architecture, which is this one. So that means that you've got the front end at the front, which is the browser, and your code running in a browser. So typically, we use AngularJS for that. Then the back end, which is the code running on your servers. For that, we usually use Scala and things like Play, Scalatra. And then finally, the data is stored in the database. We use Elasticsearch, Mongo, and other things. And these are typically referred to as sort of presentation. I'm going to turn that off because it's going to annoy me, people tweeting me. Presentation, middle tier, and data storage tiers. So this is what we're going to refer to in the rest of this presentation. Just keep that in mind. Let's move on. So the idea for this talk came about a few months back when I started getting increasingly jealous of this information radiator that one of my colleagues built. And it's for the responsive front-end sites, it shows them a lot of information about the health of the server, key system metrics, KPIs, the deployment status, health servers, and so on. So that's a really useful thing to have at the end of your desk. And compare that to what we had in my team. Yeah, it was a bit meh. So why is it meh? It's not just because it looks a bit shit. It's also because it's quite complex. It's complex as a user because I actually had to be on the VPN to access it. So if something goes wrong, you're on, I don't know, in a restaurant, you can't log in on the VPN with your phone. It's really tedious. And also it was complex as a developer because sometimes you want to change these dashboards. If something goes bad, like, I don't know, last week we had some problems and we needed to start monitoring a new queue, then it's really hard. It was quite tedious to add new things to this dashboard because it was deployed somewhere, and also it was written in this horrible PHP code. So that's one aspect. The other side of that is that it's also very rigid because it only pulls data from one source, Graphite, which is our internal monitoring servers. And also, the configuration was very much mixed in with this horrible PHP code I mentioned, which made it really hard to edit and manipulate graphs the way I said I would like to be able to do. So when something is not good, what you do, you put it in the bin, and then you say, well, let's build a better one. So let's try and build a better one. So going back to this architecture I presented earlier, so we know that we've got the data storage. This is where our data is. So it can be possibly in Graphite, which is the current, so what we have for our more legacy systems. And more we're moving towards AWS, so the Amazon Web Services, which has its own monitoring service called CloudWatch. That's what we're going to focus on for the rest of this presentation, because that's where our services are moving. So that's where the data is, and we know that we want to have the presentation layer display the graphs in your browser. So that's what we've got. Now, what about this middle tier thing? What happens with it? Do we need it? Well, so I really love Scala, but one thing I love even more than Scala is not having to write any code or maintain any servers that might go down and so on. You have to monitor the monitors. It's really boring. So can we just get rid of it? Well, let's see. What do we actually need it for in the first place? Well, traditionally, I think I've identified three things that you would tend to do on this middle tier. The first one is auth. So by that, I mean both authentication, which is knowing who the person is, and then authorization, which is determining what permissions they have in the system. Once you know that they can come in, you go, OK, great, I can query the database on their behalf and retrieve some data. And once I've got the data, I can just render it. That's the simplest thing that the middle tier does, and that's usually what it would do if you implemented it in any language. There's a few other things, obviously, that servers do, like serving the actual files, maybe caching, serving data. But let's leave that on the side for now. So let's see, can we do all of that on the client instead? Let's say we've got a static HTML page, and we're going to write all of this in JavaScript. So how do we start? We start with the auth aspect. Now, actually, AWS gives us nice primitives for that, because they support this idea of credentials that you can create. And then once you've got these credentials, which is a key and a secret, don't try and copy those. They're not real. And the region. And once you've got that, you can define the permissions that they have. So I'm going to define, actually, these credentials. All they can do is query CloudWatch. They can't spin up new servers and so on. All they can do is just read the metrics data. So now I can define them and put them in the page like this. And I've got my auth sorted. Great. So that's in JavaScript. So now I've got my auth. I can pass it into, I'm going to do a query with it. So to do that, I'm going to use the AWS JS SDK. It's an open source SDK. You can go and download it. It's the same SDK as in other languages. And it lets you query the AWS services. So you just create a new instance of the CloudWatch service with the credentials we've passed in earlier. And then you can call the method to get metric statistics. And you pass in some parameters that are going to define what you're querying. So here, we're going to actually look at the request count, so the request rates in a given load balancer for a given time, and sum it. And when we do this, asynchronously, we get the response back. That's what we see at the bottom here. And I mean, that's quite AWS specific, so we might actually transform that. Don't look at this code, but basically you transform it into a time series, which is a simple array of pairs. And in the pair, you got the first item is the time the event happened at, and then the second item is the value. Very simple data structure. So we've got our data now. We've got our metrics data. So all we need to do is to render it. So I'm lazy, so I'm not going to do that myself. I'm going to just load in Google Chart and write this. It's actually quite a lot of boilerplate here. It's quite ugly. But yeah, that's what you had to do. That's from the example on their in their docs. And in the middle here, we actually see that we add the rows in the middle of this big blob of JavaScript. And at the end, we also say, OK, select this element, and then inject the graph at that place in the page. And then we get our graph. That's great. OK, job done. Let's all go to the pub. Well, not quite, because so we've fixed the first aspect. It's no longer complex, because it's just this static HTML page in my browser. It's really easy to edit. There's no VPN crap anymore. There's no horrible PHP anymore. So that's sorted. But in terms of rigidity, we're still pulling from only one data source. We're now reading from AWS, but that's still just only one. And the configuration was mixed into all this spaghetti code that I showed you earlier, so that's not very nice, which means that it's not very easy to add and change graphs quite rapidly. So I'd say it's not better enough. So what can we do? What do we actually want? Ideally, what we want is not to have any of this boilerplate. We just want to say, I want this graph of requests, and well, that sounds very much like just an element, right? Can we do that with an element? So I'm sure, hopefully, you know where I'm going with this. So web components. Who in the room knows what has heard of web components? Cool. Who has tried web components? Oh, quite a lot. Great. So quick primer. So a web component is this idea of a custom element. So you could say, OK, there's this Google Map element that will show a map of this geoposition. OK. If you put this in your browser, it's not going to work magically, right? It's just going to do nothing. So how does that work? Well, the thing is, the idea of web components is that you can teach the browser how to what to do with this when it sees this in the page. So you can define the behavior when it sees a custom element and make it do anything you want. All of this you program in JavaScript. So once you've written the code for this, you need to import it into your page so that it's in scope. This is very much like you'd import a style sheet to sort of change the presentation of your page. This is simply using the HTML imports. And once you've got an HTML import, well, actually, all of this is, in fact, it doesn't really, it's kind of using futuristic APIs. So you need to use polyfills. And for this, we use Platform.js, which is a library Google wrote to polyfill all the web components APIs so that they work in all recent browsers. So you can really think of web components as if HTML elements are sort of your classic Lego blocks. Web components are like the Lego Mindstorm. You can do anything. So we're going to use web components. We're actually going to use a layer on top of that. We're going to use Polymer, which is this library Google wrote as well, on top of Platform.js. You don't have to use it to use web components. In fact, you can use other ones like Xtags from Mozilla if you prefer. But let's use Polymer because it has a few niceties, such as this element scaffolding, declarative syntax. So we see in this example that we just import Polymer so that we can use the Polymer element to define a new element called myGreeter, and then it takes only one attribute called name. We see at the bottom we use it, we just have a tag myGreeter, and we pass in my name, Seb, as an attribute. Now, back to the declaration, we see that the template is actually, this is what we're going to put in the shadow DOM. I'm not going to explain what the shadow DOM is, but basically, this is going to what is going to appear in your page instead of the my greeter element. And it's going to say hello and then my name, because this is the data binding syntax. So Polymer supports bidirectional data binding, which means that it's going to replace the name sort of curly thing with the value of the attribute, here, Seb. And actually, because it's bidirectional, you can also bind it to this input text, where it's going to give the initial value to the input text, Seb. But then if you change it, it's going to change the value everywhere for that variable. So this is actually really powerful, and we're going to use that throughout the rest of this presentation. OK, so let's dive in. Or not. Oh, here we go. So we've got this AWS config element. We've created a new element called AWS config. I'm going to show the implementation in a second. And it basically takes 3 attributes, region, key, and secret. And we just pass in string values to the attributes. What does this element do? Well, nothing, so that's not very useful. It just takes in some data and does nothing. There's nothing to display. It's just a configuration thing. So what do we do with it? Well, what we can do is add a new attribute. Let's call it sync for convention, and to say that sync is actually an attribute where we're going to write out what the output of this element is as data. Here we're going to output it to a variable called AWS config, and the variable is going to contain something like this, which is exactly what we had earlier, as you saw in the JavaScript. So actually, if we go to the implementation, it looks very similar to what we did earlier. So we load in Polymer, then we say I've got a new element called AWS config with 4 attributes, and then I declare how this element works. So I'm going to say I'm observing the first 3 attributes, the 3 inputs, and whenever any of them changes, I'm going to update. I'm also going to update when the element is ready, which means it's been put in the page. So what does update do? Well, it just checks that the 3 inputs are there, and if they are, we just create a new object and write it, assign it to the sync property, which will basically set it to this variable that we data bound. Great. OK, so I've got this element. By the way, all of this is open source, so there's GitHub URL, so you can all go and play with this. You can just make your own. So we've got our credentials now as a variable, so we can pass it into this CloudWatch element, which is going to abstract the same JavaScript code we had earlier, which does the querying using the SDK. So I'm not going to show the code for that, but basically, we have this element that takes the config as input, and then the parameters as attributes as well. And then it's going to have its own sync attribute that's going to write asynchronously when the data comes back. It's going to write the value into this variable, AWS metrics requests. That's going to contain time series. We also see that we can pass in an AWS dimension, sort of sub-element, just the same way you do like an option inside a select, for instance. OK, so we've got our data, and it looks very much like what we had before. Is this thing working? It looks very much like what we had before, which is this time series data. So we can pass it into the render element. Now, actually, because I'm super lazy, I'm actually not even going to write it. I'm just going to steal it from Google, because Google wrote their own custom element. I don't know if Adit did, but their own Google Chart element that wraps their Google Chart library. And you can see there's actually a lot less of this horrible boilerplate than before. So that's already a nice win. So I'm just passing in my data as rows, and then I define how it's going to look. And there we go. We've got our chart. So that's cool. And we've got all of this through web components. So what does it look like end-to-end? So end-to-end, we have we've got our 3 string attributes that we pass into the AWS config element. That's going to write it using the sync to a new variable, AWS config. We pass that to CloudWatch alongside other parameters. That's going to do the AJAX request. And when it comes back, we can write that into another variable and pass that to Google Chart. And boom, our chart appears. Great. What does that look like in code? Well, it's very similar, in fact. So we load in platform.js at the top, which is the polyfills. We import our 3 elements. And then we use them within this sort of auto-binding context that gives us the data binding thing. And that's it. This is the 3 elements. So that works for a single chart. If we end up having more charts, more request charts, you can already tell that it's going to duplicate quite a lot of code. So we end up with something like this, where there's a lot of code duplication. And as you know, don't repeat yourself. It's not very clean to copy-paste code. You shouldn't be doing it. If you're doing it wrong, probably. So how do you abstract this? Well, in typical programming, what you do is you parameterize it as a function, right? And then the bits that change, you make them parameters of the function, and you've abstracted it away. So here we're going to use an element. You're going to use an element instead, and we're going to make the two inputs is going to be the config and the load balance name, which are the only two things that change in all of this code. So we can abstract this as a new AWS requests element, and we just pass in the load balancer name. Great, and then that means we can use it, and we've done what we wanted. We've got our new AWS request element, and that displays a graph of the request for this load balancer. Great. And actually, we can do this. So we've done it for requests. We can show latency. We can show like bucketed numbers of sort of counts in a custom metric. You can do anything you want. And because we've based this on small sort of atomic modules, you can actually replace some of the pieces of the puzzle. So you can say, actually, let's fetch the data from another source. Let's fetch the data from Graphite instead of AWS CloudWatch. Graphite is a completely different server. We access it over REST and so on. But because we output this in the same data format, interesting. That's how impressive web components are. So, because we use the same data format, we can pass it into the Google chart, and it works just the same. So a small confession, we've actually cheated all along, so sorry about that. I don't know if you noticed, but everywhere we passed in the exact sort of string values for the time. Well, that's a bit stupid, isn't it? Like, that means we're always watching a given sort of time range, time interval for all our data. That's not a very useful graph. So what can we do instead? So what do we want is probably just to say, OK, I want to see the last hour of data. So how do we do that? Well, the last hour of data means that the time interval ends now. So we're just going to create a new variable that stores the now time. And where does now come from? Well, there's an element for that. So we just create a new time now element. That's going to export the time when it's initialized. And the now variable will store a date time that is passed into the CloudWatch element. So that's great, except, well, it doesn't update. Well, we can make it update. We can just pass in a refresh attribute that says update every minute. And that means that actually, the nice thing here is that when now updates, after a minute, the now value changes. And because CloudWatch is also observing its inputs, is going to do another request to fetch the updated data. And because the charting element also watches its inputs, is going to update the graph. So we've got it's like functional reactive programming, where you define the data flow, and then everything updates without having to sort of explicitly listen for special events. Nobody knows about the other things happening. It's just data bound. So we're not quite done yet, because the start time is still hard-coded. So what we said, we wanted to have a span or a time interval of 1 hour. So let's do that. Let's define a time range element that says 1 hour, and then we bind the end to now, which means that the start is going to be an output, which which we can attach to the CloudWatch element. So we've got now our time range of 1 hour. That's enforced, and when now changes, start changes. Except we're still not done, because the number of hours is fixed. What do we want? We probably want a custom number of hours, because what if your servers died a horrible death like an hour and a half ago? Well, you want to be able to change that time range. So if you say the user needs to do it, well, we want a bit of a UI element. So again, I'm lazy, so I'm not going to write my own. I'm just going to steal this one from Google, and that's what they're for. So we're just going to take the paper element, which is some custom element they've written, and that's going to export a simple integer value that we're going to bind as hours. And when I change the value here, as we can see in the GIF, then that changes the number of hours. And just the same way as when now changes, that cascades down, changes the data, and renders again. If you change the number of hours as a user, it just cascades down and changes what you see in the graph automatically. So that's pretty neat. This is what the code looks like. We're not going to spend too long, but yeah, you can review the slides later. Another thing we did, which we cheated a bit on, is we've hard-coded a secret in the page. Now, if you are a security expert, or even if you're not, you probably should know that this is not a good thing to do. So you don't want to put secrets in the page, because if someone sees that page, that means they can access well, they can query how slow your servers are. That's not super dangerous, but it's still not a very nice thing to do. So you probably don't want to do that. But how do you do it? Because you need to authenticate with your servers. Well, What we can do is we can use this magical thing called the AWS Web Identity Federation. And this is provided by AWS. And it lets you acquire a token with a third-party auth provider like Google, Facebook, or Amazon. And then you trade that token for a temporary set of AWS credentials that you can define permissions for. And this is what I've done here. We've written a new AWS identity element that wraps the Google sign-in element that Google actually provided. They had to write it for me, so that's nice. And that exports the same AWS config object as the previous element did. So you can just substitute this sort of hard-coded config we had previously with this one that does it in a safer way and without revealing any secrets. So yeah, that's nice. So let's do a live demo. Maybe. OK. All right, so let's reload this and see if it still works. OK. So this is just a demo radiator I've made. So we see on the right that there's these tag API metrics. So that's metrics. Actually, they appear here because they fetch from Graphite. And the way we restrict auth for Graphite is simply IP-based. So I have to be on the VPN for this. And the other thing we see is these weird rounded colored dots, and these represent deploys to either our production or pre-production environments, whether they've succeeded or failed. So this is this is data that's live from today, from now. And so as I said, we're going to use this AWS identity element to do the auth. So this is the Google sign-in element. This is what it looks like. This is the button for it. So I'm just going to click it and see whether that works or not. So I'm just going to need to auth with Google. And that trades a token, that gets a Google token back, trades it with Amazon, and gets a set of temporary credentials that I can use then to query CloudWatch. Everything is data-bound, and this is the data appears here magically. So we can see things like this. So you've got the latency, requests, and all the bucketing. And this is a static page this is just a Python server that serves a static HTML file. There's no servers involved apart from the AWS services. And that's all using web components. And as I said, because you can change that, you can simply change what time window you're looking at, and it automatically updates just through the magic of data binding. So that's also really neat, because you don't have to write complex logic to update. Yeah, so that's for the demo. Right, obviously that's going all wonky now. So does that mean we can all, say, fuck servers? I'm just going to write my JavaScript code from now on, and don't need to do any more servers. I'm just going to talk to the database until the end of times from now on. Well, not quite. Partly because, if you use the web components, the support is still fairly limited in that it doesn't support all browsers, especially all the browsers, and you might want to support that. The other thing is, as we saw, we're querying the database directly from the browser. That doesn't really scale very well. So for things with low traffic, like something that developers use or even internal users use, that's fine, you can use that. But I wouldn't put that on the front of the Guardian website. I don't think Patrick would like that very much. So that would not scale very well. The other thing is we want to have a system for authentication, especially if you're doing read-write, but even reading sort of sensitive data like this. So for this, you need to the only sort of component you can rely on is the backend. You can't rely on the front end to do that, because the front end, anyone can write it. So you need support from your backend services, and you can do that with IP restrictions, or you can do that with things like AWS policies. But the policies are quite coarse-grained, so you couldn't say, OK, you can only update this column in this database. So there's a bit of sort of limitations there that make it a bit harder to use for write services. But you can still do it for things like this and quite a lot of other cases. In the future, I think there's more things we want to do with this dashboard. This is kind of just the beginning. So showing deploy lines on graphs, or showing KPI graphs, like how many images are added every day. Surfacing our JavaScript errors. We use the Sentry service to capture them. So it'd be great to see when there's a spike after a deploy. So you've probably broken everything. And see the server health. And yeah, so a lot of more things you could add to these servers carrying on the same pattern. So what have we learned so far? I think we've shown that it's possible to remove this middle tier, and that makes the whole system a lot simpler to maintain and to edit. It works in a variety of cases. The other thing we've learned is that you can use web components as atomic programmable blocks, like Lego blocks, and then you can combine them using data binding or composition or events, and that lets you create quite a complex system out of very simple blocks that you can then substitute. And so that's it. That's all I've got. And as I said, all of this is open source, and you can check it out. So I'll recommend you go and play with it and file like bug reports and everything, and play with it at home. It's safe. That's all. Thank you very much.